Hello there, and welcome to another Unity tutorial. So this tutorial will be the last video in our Create a Floor is Lava game in Unity series. So what we're going to do in this video is just swap out the last remaining meshes, the two triggers, the end trigger and the score trigger, and we'll replace them with an animated mesh. And there's also a couple of little bugs that slipped through the cracks in previous videos that we'll sort out in this one. And then we'll also animate our lava texture in our environment using a script rather than the animator. Okay, so what we're going to do is we'll open our prefabs folder from the project window, and we'll just open up the end trigger prefab. So we're going to need to do a couple of things here. First of all, let's remove the mesh filter and the mesh renderer components because we're not going to need them on this object. Next, we're going to change the scale so it's 1 on all axes. But what I'm actually going to do is I'm going to transfer these values into the size for the box collider so that the collider still maintains this size. So we have 1 on the X, 3 on the Y, and 4 on the Z. Now you can see that's become huge, but when we set the scale back to 1, 1, 1, you can see it's got the same size now. Okay, now it's important that we set that scale back to 1, 1, 1 because that's going to affect children of this object. So next, for the end trigger, we're going to add a new 3D object, and let's add a cube for this one. This is the end. We'll remove the box collider because this object won't need it. This is just going to be an animated object as like a visual cue for the end trigger. Next, what I'm going to do is I'm going to click on Add Component, and we're going to look for animation, right? Not animator, animation. Now this is the legacy way of adding animations to an object in Unity before the animator component was integrated. So we can add a list of animations here and then we can change them through code. Now the reason I've decided to use this component over an animator is because this object is just going to play the same animation endlessly. It never needs to change animations or anything like that. It's just going to have one. So what we can do is we can, add the animation here once we've created it, make sure play automatically is turned on. And then as long as our animation is set to loop as its repeat or wrap mode, then it should just endlessly keep playing that animation until the scene ends. So to create an animation that works with this component, it's the same as creating any animation within Unity. We need the animation window. So I'm going to go to Window, then I'm going to go to Animation and select Animation, and I'll just dock that down by my game window here so we can see what we're animating. Maybe just move in a little bit slightly, and then I'm going to click Create, and we'll go and store this in our animation folder, and we'll call this Anim End Trigger. Okay, so now I'll hit the record button in the animation window, and I'm going to create a very simple little animation now, just like we did for our enemy mine agent. Okay, so I've got a very simple little animation here of just the cube rotating. So the next thing we need to do is add a material to our animation. Actually, I'll just go out of record mode quickly. Maybe we'll stop playing our animation too. So I've already created a couple of new materials in preparation for this tutorial. So let's drag our crystal material onto our cube here. Let's just see how that looks. What's the other one look like again? Yeah, maybe we'll go with that one. And I might just maybe adjust the color. Maybe we'll go with like a pinkish or a purplish. We'll adjust the emission as well. Yeah, that looks pretty good. Okay, so this is our end trigger now. It's animated, and because we are working with the prefab, it's going to automatically apply to all the existing versions of the prefab in our scenes. Now there is one important thing to note when we're using the legacy animation component, right? And that is like, how do we make this animation loop? So I found the animation just by clicking on it in this variable for the animation component here. We can see it get highlighted right there. And if we click on it in the project window, we can see that we have a wrap mode. So all I'm going to do here is change the wrap mode to loop. Now we can go back into our scene, and I'll just reposition the camera so we can see the end trigger. There it is, right? In fact, actually, I might actually just make the scale a little smaller. Let's do that. Let's find our end trigger again. Now this shouldn't affect the animation because the scale isn't animated. Okay, cool. So let's hit play and just double check that that this works. I might just mute the audio. Okay, so we can see that it's animating, right? And it seems to be looping just fine. And that's good. Excellent. Okay, so now we're going to do the same thing, but for our score trigger. So let's find the score trigger prefab. Right, there it is, and let's open it. Now, remember that the first thing that we want to do is we want to remove the mesh filter and the mesh renderer. We want to make sure that the scale is set to 1, 1, 1, right? And if you want to adjust the size of the trigger, just play with the collider itself, the actual trigger. Next, I'm going to create the 3D object as a child of this. Now, I'm going to use a sphere instead of a cube for the score triggers. Then, just like before, we remove the sphere collider, we add an animation component, and then we can start animating it. So I'm going to create a new animation here in our animation folder, and we'll call it anim score trigger. And I'll hit record, and now I'll create another simple animation. Okay, so that animation will do me for my score trigger. So we'll just turn record off and we'll stop the animation. And then the last thing is add our material. So I'll add my crystal material there, and let's just give it one more look. That's all right. Okay, that'll do me. So just like before, we need to make sure that the animation that the animation component is going to play at the moment is set to the one we want it to play right away. So let's just drag our score trigger animation, score trigger, into the animation variable for the component. And then lastly, we'll select our score trigger animation and make sure that its wrap mode is set to loop. So now let's just test that out. Where's a score trigger we can have a look at? Okay, let's hit play. Okay, there we go. So the score trigger material is actually kind of a transparent material, but we can see it kind of moving a bit. I could have made the scale a bit smaller. That's all right. Maybe we'll just move the score trigger up slightly. So I'm going to go out of play mode. Okay, I'm out of play mode. So let's find our score triggers. There's one there, and the other is on a platform. So it's probably a child. There it is there. So we'll just select both of those. We'll make sure that our point here is set to center, and then we'll just, drag it up ever so slightly, maybe a little bit more. The other thing about these score triggers is because the child is the animated object. If we change the scale of this object, the animation will still play fine because it's changing its own scale for the the child object independently of the parent scale. So if we were to change this to 0.5 maybe. Oh, I should be doing this for both of them actually. Whoops. So we'll select both of them, and we'll just go 0.5. Oh, actually, no, we can't do that because that one has a different scale because it's the parent scale is quite large. So yeah, what we could do is we just quickly drag that out, select them both, 0.5, 0.5, 0.5. So it's much smaller. We'll make the box collider twice the size to compensate for that. And then we'll just make our score trigger a child of platform B again. And now, they're much smaller. And if we hit play still, the animations will still work. And it's kept its, new scale. Okay, so now that we've done that, we can actually close these folders in the project window because we won't need to access them anymore. And we'll open the scripts folder. Now, the two bug fixes I want to implement, one has to do with the player controller, when the player controller gets teleported. And if it's parented to something like a moving platform, the way it is at the moment, it never actually unparents the player from that platform if they're teleported at the same time. So they'll be teleported, and then the movement of the platform will still be affecting them even though they aren't actually on the platform. So that's one bug that I want to sort out. And the way we sort that one out is in our player controller script. So we'll open that up in Visual Studio. Okay, so here's our player controller script. And we want to just scroll right down to our teleport position function, right? Now, what we're going to do here is right before we change the position of the player, we're going to open a brand new if statement here. And what we're going to check is transform.parent is not equal to null. So if we have a parent, what we want to do is access transform.setParent, and we're going to pass it null. And what that will do is it will just remove the player from their current parent and put them back into space independently so that they're not being affected by anything else. And that's all we need to do for that bug. So that should fix the player being affected by the moving platform's movement if they're teleported while they are still actually on the platform. Now, I encountered this bug when I had the lava trigger just slightly too high, and the player was able to hit the lava trigger while being on sort of the edge of the moving platform. Now, the next bug I want to fix is actually to do with our mine agent. So what's happening is when our mine agent detonates, its collider is actually remaining on. So even though it's detonated, you can still run into it and physically be stopped by it. So to fix that bug, we'll go into our mine agent script, which I already have open here. Okay, now in this script, we want to scroll down to the detonate function. So let's find our detonate function. Here it is here. Now, we have two for each loops here as it stands. One of them is looping through the colliders around the mine agent when it detonates to try and figure out if the player is close enough to take damage. And the next one is looping through all of the pieces of our fractured pieces and just adding the explosion force to the rigid bodies. Now, we're going to put another loop in between these two, right? So we're going to say for each collider, and we'll just call it collider. In get components, multiple, right? Or plural, I should say. And we're going to look for just the base collider type here. So in other words, we're going to loop through every collider object that's attached to this object here. Now, all we want to do here is say collider.enabled is equal to false. So that's going to turn each of the colliders on the mine agent object. It's going to disable them. So that'll be the physical collider that the player runs into, and it'll stop them from moving forward, as well as the trigger collider that's used to detect if the player is close or not. Okay, so you can see we've got unsaved changes to two of our scripts here. So to save both scripts at the same time in Visual Studio, I'm just going to click on the Save All icon, or you can press Ctrl-Shift-S, and you can see those have been saved now. So that's everything we need to do to fix the bugs. Now we'll move on to creating the scrolling lava script. Okay, so I'm back in Unity. Now this new script, we are actually going to want to attach to the room itself. So let's just find the prefab for the room and open that up. Here it is. And so before we get into the script, let's just have a think about how this is going to work. So what we want to do is we want to change the UVs or offset the UVs, the texture, consistently by a little bit every frame, right? But the UVs, we don't want it to, change all of the materials. We only want the lava texture. Now, this in the mesh renderer component for the object, we can see the materials array, and there's two values in here. The very first one at an index of 0 is the walls texture that's applied to our walls. And at an index of 1, we have the lava texture. So we only want to scroll this one. So in our script, we're going to need to be able to specify which index for the material that's actually being scrolled. So anyway, let's go ahead and create the script. So I'm going to come down, actually we'll create it in our scripts folder, so it goes straight in there. So I'm going to right click on the scripts folder, go to create and select C# script. And let's just call this scrolling texture. Okay, good, so our script has been created. Now let's just go ahead and attach it to our room here. So I've added the scrolling texture script to our room. And now let's open it in Visual Studio. Okay, here we are in Visual Studio. So first of all, we can get rid of these two namespaces at the top. This is going to be, a fairly simple script. We're not going to need to do too much, and we won't need to use those two namespaces. So the first thing we'll do is we'll create the variables we're going to need, and we're going to need a few here. Okay, so we'll create a serialized field. It'll be private. This one will be an integer, and let's call it mat index and give it a default value of 0. So this is going to specify which of those material indexes represents the material that we're going to want to apply the scrolling texture to. Underneath that, we'll create another new variable. I've just pressed Control D to duplicate that line to the next one. This one's going to be a float, and we'll call it scroll speed. And we'll give it a default value of 0.1f. Next, underneath that, we're going to have a Boolean, and we'll call this one scroll x and give it a default value of false. So that's going to represent, if we have that turned on, it's going to scroll on the x-axis of the texture, and then we're going to have another one for the y-axis. Now those are all the serialized variables that we're going to need. We will actually need one more variable, which will be a private mesh renderer, and we'll just call it mesh renderer. And that's going to store a reference to the mesh renderer of the mesh itself. Then we'll use the awake method instead of the start method. So here we're just going to set our mesh renderer reference. So we'll say try get component out, and then we'll just pass it the mesh renderer variable. Okay, now we are going to use the update method here, but we actually need to go ahead and define another function that we're going to use in the update method, right? So this is going to be a private, private method that will return a vector2, and we'll call it calculate scroll value. It's going to have no parameters or anything like that. Then within here we'll have a local variable which will be of the type vector2, and we'll call it scroll value, and we're going to set it equal to vector2.0. Bloody autocorrect. Oh my god. Okay, now we'll have another local variable underneath that. We'll call it scroll step. It says float, and we're going to set this equal to scroll speed times time dot time. Okay, next we just need to check, which axes we're scrolling. So we'll say if scroll x is equal to true, then we are going to grab the x-axis of our scroll value and set it equal to scroll step. If scroll y is equal to true, so same thing, scroll value dot y is equal to scroll step. Good. Then after that, we can simply return our scroll value, right? So this is calculating how much to move by every frame. So now in the update, now that we've got that, we can actually apply that to the texture. So let's open an if statement here. And here we actually want to check for 3 conditions, right? So in the if statement, we first want to make sure that there is a mesh renderer attached to this object. So we'll say if mesh renderer is not equal to null. And we want to make sure another condition is also true after that. So we use 2 ampersands for the and symbol. Next, we want to make sure that our mat index is less than the materials or the available materials for the mesh renderer. So we'll say if our mat index is less than mesh renderer dot materials dot length. Oh, length. Yep, there we go. Materials plural. Okay, next we'll check one last condition. So even if if there's a slot for materials, right? So if we've got 3 elements in our array, it doesn't necessarily mean there's anything assigned to that. So that's the very last thing that we need to check. We need to make sure that there's actually a material in that slot. So here we'll say mesh renderer dot materials plural. And this is an array and we want to access a specific index. So we'll have a set of square brackets after that and we'll just pass it mat index inside. Now, if all of that runs, we know there's a mesh renderer and we know that there's actually a valid material to have the scrolling applied to at the desired index. So here is just a matter of calculating that scroll value and then applying it to each of the different texture maps in the material, right? Because the material is made up of more than one texture. So first of all, let's create a local vector2 variable. We'll call it scroll step. And let's set that equal to our calculate scroll value method, right? Or the result of that method. Then here we access our materials through our mesh renderer and the material at the mat index. And we use a method called set texture offset. Now in here, we pass it 2 things. We pass it the name of the actual texture that we want to offset, and then we pass it the offset value. Now the names for each texture can actually be found in the shader settings. I'll just put up a quick little clip here of where to find them. So each texture slot in a material corresponds with one of the names in this list. So first of all, we'll do the albedo. So that is underscore main text, and we write that as a string. And then the second parameter will be our scroll step variable. Now I'm just going to duplicate that because all we're going to be changing in the next lines is the name. So the next name is metallic gloss map. The next name after that is bump map. After that, we have parallax map. After that, we have occlusion map. Then we have the emission map, of course important for our lava texture. And then after that, we have the detail mask. Oh, no space. And that should be it. That should be all that's required to get the texture scrolling. So let's save the script, Control S, and then head back into Unity and set it up and see it in action. Okay, so I'm back in Unity now. Let's just select our room. I'm still in the prefab here as well. We'll scroll down to our scrolling texture script. Now, let's just minimize some of these so we can see what we need to see. So we've got the mesh renderer here. Now, remember that we don't want the walls to scroll. That's at element 0. We want element 1 to scroll. So I'm going to set the mat index to 1. And then I'm going to turn on both scroll X and scroll Y. Okay, now let's go back to our scene. And, you know, we can probably select our room here too. And yeah, let's hit play and see what happens. Okay, so you can see that our texture is scrolling now. And in fact, if I select the room, it's scrolling really quickly. So if we were to, you know, reduce the scroll speed, let's say let's put an extra 0 in there. You know, that's a lot slower. It's still noticeable in the actual game. That might even be too quick. Now you can see it's going on an angle here, right? If we want it to, you know, scroll on only the X or the Y, you just make sure only one of them is checked. So now it's only scrolling on one axis. Now it's not scrolling at all. And yeah, with both of them enabled, it scrolls on both axes. And if you want it to go the other way, you just set your speed to a negative value. So that's it for this tutorial and this series. I think this is a good spot to end it. We could infinitely keep adding stuff onto it and improving things, but in terms of like a first game made with Unity and a first entry into the Unity engine and making something that looks pretty decent and you know, just getting your head around the core mechanics of like a first person sort of game, I think this project does a pretty good job of that. So if you made it all the way through, you know, good on you. I hope you have ended up with something that you're proud of, and at the very least, I hope you learned a few valuable lessons along the way. I'm sorry it took so long to complete this series, but between, you know, my old job and then becoming a uni student, it just, you know, it didn't pan out very well with time and stuff. So, but yeah, I hope this series was helpful in some way. But as always, thanks for watching. If you liked the video, please leave a like. And if you want to see more game development tutorials like this, then I'd encourage you to subscribe to the channel. Have a wonderful day.